the product and the quotient rules. So we've been learning about derivatives and how to take the derivative of specific functions, but now we're going to learn two more rules that allow us to take the derivative of more complicated looking functions. So if f and g are differentiable functions of x, then so is their product f times g. That is, f times g prime is equal to f prime times g plus f times g prime. Or in notation as f of x times g of x prime is equal to f prime of x times g of x plus f of x times g prime of x. So in other words, to take the derivative of the product of two functions, you have to take the derivative of one, fix the other, and add to that the function that you took the derivative before, fix that, and then take the derivative of the other one. A lot to process, which is why I give you the shorthand here and then the longhand here. Okay? You will probably need to take a screenshot if you're online, because we're going to be referring to these rules. If you're in class, then you'll want to be able to reference both of these rules throughout the entire class. So write them on the next pages if you need to. The quotient rule. The quotient rule allows you to take the derivative. It gives you a rule that gives you a way of taking the derivative of a quotient. So suppose f and g are differentiable functions of x, then so is their quotient, f over g. That is, f over g prime is equal to f prime times g minus fg prime over g squared. Or, with f of x and g of x, f of x over g of x prime is equal to f prime of x times g of x minus f of x times g prime of x all over g of x quantity squared. Some people remember this as they think of the numerator as high, the denominator is low, and they write low d high minus high d low over low squared. Meaning the d high means you take the derivative of the numerator, and then vice versa. So let's go through some examples. You got the rules? Yes?
Yes.
All right, let's go with it. Let's do some examples. So to learn these rules, the best way is to apply them. So let's first write out the rule here, because we have on this page products. So remember, f g prime is equal to what? Good, f prime times g plus f times g prime. You got it. So now what we're going to do, now given this problem, you could distribute the x to the fifth and you can take the derivative the way you normally do. However, I just want to illustrate the product rule here. Okay, so let's take x to the fifth. Let's just write the rule applied. So we would let this be equal to f, this be equal to g. So we would have x to the fifth prime times 1 minus x plus x to the fifth times 1 minus x prime. That's direct application of the product rule. This is equal to, what's the derivative of x to the fifth? Come on, derivative experts. What's the derivative of x to the fifth?
5x to the 4th.
There you go, 5x to the 4th. So we have 5x to the 4th times the quantity 1 minus x. That should be a parentheses. There. Plus x to the 5th. What's the derivative of 1 minus x? -1. Good. So multiply that by -1. And then we distribute the 5x. Let me erase that. We distribute the 5x to the 4th to each part of this because we're multiplying this times this quantity here. So this is equal to 5x to the 4th times 1 is 5x to the 4th minus, what's 5x to the 4th times x? Can't hear you. Good, 5x to the 5th. So you have 5x to the fourth minus 5x to the fifth, and what's the rest?
Minus x to the fifth.
Minus x to the fifth. Good. Simplify. What do we get?
5x to the fourth minus 6x to the fifth.
Very good. And that's your answer. So you just use the product rule. Okay? Now, what questions do you have? None? Okay, I see heads shaking, so we'll go with that. Now, in part B, we have y is equal to 4x minus 1 quantity squared. You have 4x minus 1 quantity squared. The way it's set up, we don't know how to differentiate this kind of function yet, the way it's set up. Here, we're going to learn a rule in the next section called the chain rule that will allow us to differentiate this function as it is set up. But since we haven't gone over that rule yet, and I have 4x minus 1 quantity squared, what can you do? Yes?
You can do the quantity 4x minus 1 times the quantity 4x minus 1.
Good. You can rewrite this as the quantity 4x minus 1 times the quantity 4x minus 1, and then it looks like a what? Looks like a what? A product, right? So you can use the product rule. Find the derivative. Would you like a couple minutes?
Yes.
Go ahead. Find the derivative. All right. So how do we take the derivative here? You want it? Go for it. Not everybody at once. Bless you. Go ahead.
Be 4 times 4x minus 1
Good.
plus 4x minus 1 times 4.
Times 4. You got it. So we took the derivative of 4x minus 1. We got 4. And then we just wrote 4x minus 1 here, plus, then we fixed the first, and then we took the derivative of that. What do you do from here? Distribute. So we get
16x
mm-hmm,
minus 4
mm-hmm,
plus 16x minus 4.
good. And what do we get here?
32x minus 8.
32x minus 8. You got it. Very good. Both of you. What questions do you have? All right. So let's add another function to the party. So we have x times the quantity x squared minus 3 times the quantity 2x squared plus 1. And we need to find its derivative. We need to find the derivative. So you can think of this, I see faces like, what do you want us to do here? It's still using the product rule, but in a different kind of way. Yes, go ahead.
Well,
Go ahead.
I was gonna say, should we just put the, x with the first?
You could. You
So
could.
it's just 2.
You could. So the suggestion was, can you just distribute x to x squared minus 3 and then multiply the 2? Yes, you could do that. Or if you wanted more use of the product rule, you could put this, think of this as x times that quantity and use the product rule a couple times. You could. Which way do you prefer? Distribute. Okay. So you would rewrite it, you said, as what now? If you mean quantity, tell me quantity. If you mean quantity, tell me. Do you want parentheses somewhere?
Yes,
Oh.
around x to the third minus 3x, and then around 2x squared plus 1.
Good. So you want the quantity x cubed minus 3x times the quantity 2x squared plus 1. Good. Now use the product rule. Would you like a couple minutes?
Yes.
Okay. All right. So we have our function as x squared minus 3x, the quantity x squared, I said x squared, let's read it right. The quantity x cubed minus 3x times the quantity 2x squared plus 1. What do we have for our derivative?
3x squared minus 3.
If you mean quantity, make sure you say that, okay? So you mean the quantity 3x squared minus 3?
Yeah.
Yep. Okay, good.
Times 2x squared plus 1.
Do you mean like this? Or what do you mean?
Yeah, like that.
Does everyone agree? Let me tell you why it's not the same. If you write this times this, it looks like you're saying 2x squared times all of this, but if you mean times this entire thing, you have to say times the quantity this. Does that make sense?
Yes.
Okay, so what do you mean?
Times the quantity 2x squared plus 1.
Okay, you got it. Good. Go ahead.
Plus the quantity x to the third minus 3x.
Mm-hmm.
Times the quantity 4x.
You got it. Very good. Now, what do we do from there? Distribute. Go ahead.
Six x to the fourth
Mm-hmm.
plus 3x to the second
Mm-hmm.
minus 6x to the second
Well,
minus 3
hold on, let me make that 6 a little bit better. 6x to the second, go ahead.
minus 3
Mm-hmm.
plus 4x to the fourth
Mm-hmm.
minus 12x to the second.
Good. Very good. Now what do we do from there?
Combine.
And you have like terms here. You also have like terms here. And then you have your constant. So tell me what we get when we combine like terms.
10x to the fourth
Mm-hmm.
minus 15x squared
Minus 15, you said?
yeah,
15x squared
minus 3
minus 3. Does everyone agree? Yes? No? Hello? All right, very good. Very good. Okay? So you know the product rule. Now let's use the quotient rule. Let's use the quotient rule. What is the quotient rule?
F,
Go ahead.
F prime times g.
First is f over g prime
Oh yeah,
is equal to what?
f prime times g
Mm-hmm.
minus f times g prime
Mm-hmm.
over g squared.
You got it. Good. So that's the quotient rule. Now let's apply the quotient rule. You'll get to the point where you don't need to write the primes in whenever you're actually applying the rule, but I'll do it for the first one just so you can see where it's being applied. Okay? So we're going to assume our numerator is f and our denominator is g. So our derivative of the function y equals 3x minus 9 over 2x plus 4 is going to be equal to the quantity 3x minus 9 prime times the quantity 2x plus 4 minus the quantity 3x minus 9 times the quantity 2x plus 4 prime, all over the quantity 2x plus 4 squared. So then we actually take the derivatives. Am I moving too quick? Okay, so now we differentiate. Whenever we differentiate, what do we have?
3 the quantity 3
3 times the quantity what?
2x plus 1
Good. You can continue or someone else can pick it up, whatever you want. Go ahead.
minus
Mhm.
quantity of 3x minus
times 2. Good, very good. All over the quantity 2x plus 4 squared. You don't have to expand that. You can leave it as it is. Okay? You can leave it as it is. And then this would be equal to, now we distribute and we simplify. Distributing, we have to distribute the 3 to the 2x and to the 4. So that gives us 6x plus 12. Now here you have to be careful, right? Because you're subtracting this quantity times this number. So you have to distribute your negative. So this would be a negative and this would become a positive, right? So we're going to distribute the negative and we're going to distribute the 2 at the same time. Okay, so this is going to become what? Plus 18, very good. All over the quantity 2x plus 4 squared. Now what happens?
Yes.
You
What?
cancel what?
The 6x.
You cancel the 6x's and then we're left with what?
30 over the quantity 2x plus 4 squared.
Good, 30 over the quantity 2x plus 4 squared. And that's your final answer. What questions do you have? Okay, so in part B here, we have y is equal to 3x squared minus 9x plus 11 over 2x plus 4. Would you like a minute to try it? More than a minute. Would you like 3 minutes to try it? Okay, I'll give you 3 minutes to try it. Okay, so you can jump right in and tell me what you got for your derivative. Go ahead. So you do not have to write the primes. You can tell me the step after that.
So, like, the second step basically?
Yes.
Okay. Declining 6x minus 9 multiplied by declining 2x plus 4
Good.
minus the quantity 3x squared minus 9 plus 11.
Minus 9 plus 11?
Yes.
You're missing something. Minus what?
Oh, 9x, sorry.
9x, good. Plus 11.
Multiplied by declining 2x plus 4 over declining 2x plus 4 squared.
Careful. Here, you fix 3x squared minus 9x plus 11, and you said multiply that by the quantity 2x plus 4, but you, by 2? Good. So by 2. And then divide all of that by?
Declining 2x plus 4 squared.
Good. Very good. Any questions so far? Okay, good. What do we do from here? We don't stop. We keep going. Go ahead. Go ahead. You said distribute? Well, you can go in the back.
Then you would simplify it
Mm-hmm.
so it would be 12x squared
Mm-hmm.
plus 24x minus 18x minus 36.
Right.
And then minus the quantity 6x squared minus 18x plus 22.
Plus 22. Good. And
Yeah.
put all of that over.
2x plus 4.
Good. 2x plus 4 quantity squared. Good. Now, from there, you can keep going, or someone else can pick it up from there. I'm okay either way. If you want it, go for it. Don't fight over it. Yes.
6x squared plus 24x minus 58.
So what did you do? This is a quantity here.
Oh, sorry, I distributed the negative 1.
So distribute that negative 1 here, right? And then you get 12x squared plus 24x. minus 18x minus 36 minus 6x squared, running out of room, plus 18x minus 22 all over the quantity 2x plus 4 squared. Now from there, go ahead and tell me what you got.
6x squared
Mm-hmm.
plus 24x
Minus
minus 58
58.
over the 22x plus 4 squared.
You got it. Good. That's your answer. What questions do you have? Very good. Okay, so now in part C, we have x divided by the quantity x minus 5 times x minus 4. And we need to find the derivative, y prime. What's your approach here?
Oil on the bottom.
You're avoiding the product rule. So that's fine. You can go ahead and rewrite it if you wish as x over what? X squared, go ahead. Mm-hmm. Plus 20, good. And then you can apply the quotient rule. And I'm going to draw a line here just to separate all of that. Part B from part C. Okay, would you like a couple minutes? Okay, take a couple minutes and find the derivative. So how do we find the derivative, or what do you get here? Does anyone need to see the primes? Go ahead, Tony. Yes, you can go ahead. 0? Ah, question. So the question was, is the derivative of x 0? What's the derivative of x? 1. Okay, so now knowing the derivative of x is 1, make the adjustment and tell me what you get. Two x minus 9. Does everyone agree? What else do we need to write? What do we need to do with that? Quantity squared. Good. Quantity squared. You're almost there. You got it. Okay? So, we have 1. We differentiated x. We got 1. Fix the denominator. We have this minus the numerator fixed times the derivative of the denominator over the denominator squared. Good. Now, from there, what do we do? Simplify. So what do you get? Good, by the way. What do we get here?
X squared
Mhm.
minus 9x plus 20
Mm-hmm.
minus 2x squared plus 9x
Good.
over the quantity of x squared minus 9x plus 20 squared.
You got it. And now what happens?
The 9x cancels.
Good.
And then you're left with negative x squared plus 20
Good.
over
20. Over.
x squared minus 9x plus 20 squared.
Good. Very good, all of you. This is your final answer. What questions do you have? All right, so now you have the product rule and the quotient rule in your arsenal for taking derivatives. The last page just says, note that you can use the product rule and the quotient rule in applications like revenue and cost. So make sure you go through example 4 on page 855 in your books and let me know if you have questions, because this is the application of these two rules to those concepts. Okay? What questions do you have? All right, that's the product and quotient rule.